Area and the Pythagorean theorem. If you recall, the Pythagorean theorem states the square of the hypotenuse is equal to the sum of the squares of the other two sides. And if you're like me, you are singing that song in your head right now. A squared plus b squared is c squared. So remember that formula. A squared plus b squared is equal to c squared, where c is your hypotenuse and a and b are what we call the legs of our right angle triangle. So remember that the hypotenuse is directly across from your right angle, so it's the longest side of your triangle, and a and b are your other two sides. So we're going to use Pythagorean theorem to work out the area of some triangles today, some areas of some right angle triangles. So for each of the following figures, we're going to calculate the perimeter of the figure and then the area of the figure. So sometimes it will be easier to sketch the diagram with a different orientation, and that's okay. You can do that if that's easier for you. So right now we're looking at this triangle and it's hard for us to figure out which side would be the base. It's really easy to think that this side, so our hypotenuse would be the base, but that's not what we want for this triangle. So if it's easier for you to redraw it so that all of your right angle triangles are in this orientation, then go ahead and do that. So your 15 is directly across from your right angle. And then we have our 6 down here at the bottom. So in order to figure out the perimeter of our figure, we first need to figure out the length of side A. So if we think about using our formula, so we know that a squared plus b squared is equal to c squared. So we have done substitution of formulas when we did Pythagorean theorem in our last unit. So that first part of our lesson today, you've done a version of this already. So we don't know what a is, so we're going to keep a squared written out. We do know that b is 6, so this is our b right here, that's our base, and across from our right angle is our C, so is our 15 centimeters. So B is 6 squared and C is 15 squared. Okay, so 6 squared is 36 and 15 squared, or 15 times 15, is 225. When we looked at Pythagorean theorem, we learned that we have to get our letter all by itself. So anything that is not on the same side, anything that is on the same side as a squared has to be moved over to the other side. And we did this in a couple of different ways. We looked at just taking this value, and when we bring it over to the equal sign, we do opposite signs. If you want to think about it as, okay, in order to get rid of my 36 on this side, I have to subtract it. So I'm going to subtract it from this side. And because I want to keep my formula balanced, I have to subtract it from that side. So these two end up canceling each other out. So 36, subtract 36 gives us 0, and then we can calculate 225, take away 36, which gives us 189. So that's one way to think about solving equations as well, showing that step this way. The next thing we want to do is we want to go from a squared to a. And we talked a lot about that in our last unit. The opposite of squaring a number is square rooting a number. So this is that sign that sort of looks like a division symbol, but with a check mark out front. And we looked at how do we figure out that formula or that symbol on your calculators. Sometimes you'll see that symbol with having a 2 up here, and that's okay to use that one, or sometimes it'll just show the general check mark right there. So I'm going to work out the square root of a, and it doesn't work out to be a nice whole number. So the value of a is about 13.7. I'm going to keep one decimal place, and my unit is centimeters. So when I'm calculating the perimeter of this shape, the perimeter is equal to all 3 of my sides added together. So I have 13.7 plus 6 plus 15. So the perimeter of this shape, when I add those all together, gives us 34.7. And my units are centimeters. So now that I've calculated my perimeter, I found the value of all 3 of my sides, I can now calculate my area. So the area of a triangle is base times height divided by 2. And this is why it's so important to find all 3 of your sides, or at least the legs of your triangles, because your base is your 6 centimeters and the height of your triangle is your A. So your A and your B, so the legs of your right angle triangles, are your base and your height when you're calculating the area. So I have my base as 6 times my height, which was 13.7, and I'm going to divide this by 2. So I'm going to calculate this value again. So 6 times 13.7 gives me 82.2. Divided by 2 gives us 41.1. And my units is centimeters squared, because now we're dealing with area. So that seemed like a lot of work to find out just the area and the perimeter of this rectangle or this triangle, but these are the steps you will need to take to solve this question. Example number 2 looks at a parallelogram, and this parallelogram, again, we're going to have to use Pythagorean theorem to solve for the height of my parallelogram. So the first thing I want to do is calculate my perimeter of this shape, and then I want to calculate my area. So remember a parallelogram, because my sides are parallel, my sides are also across from each other, are also equal to each other. So when I'm calculating the perimeter of my shape, my dimension along the top is going to be the same as the dimension along the bottom, and my dimension along the right hand side is going to be the same as the dimension on the left hand side. So if I add up these two dimensions here, I have an 8 and I have a 2, that gives me a length of 10 meters along the top. So the perimeter of my shape, so this is going to be 10 as well, and this over here is 6. So I have 10 plus 10 plus 6 plus 6. And the perimeter, when I add those all together, 10 plus 10 is 20, 20 plus 6 is 26, and 26 plus 6 is 32. And my units are meters. So now I want to figure out what the height of this shape is. In order to do that, you'll notice that this diagram has been split up so that we can draw a right angle triangle in the right side of my shape. So right here is my right angle. Across my right angle is my hypotenuse, or my C value, which is 6 meters. I can use my 2 as my base, which gives me the height of an A. So I need to calculate the height, or I need to calculate the A in my triangle in order to calculate the area of my parallelogram. So in order to do that, I'm going to do this calculation down here. I'm going to do it over here so that I have a little bit more space to work with. So again, the formula for Pythagorean theorem is a squared plus b squared is equal to c squared. My a I don't know. My b is 2, so 2 squared, and my c is 6, so 6 squared. A squared plus 2 times 2 is 4, equals 6 times 6 is 36. So the other way, again, remember we talked about this, I can take my plus 4, I bring it over to the other side of the equal sign, and the opposite of adding a number is subtracting a number. So if you wanted to do it that way, you can. So just simplify it by writing 36 take away 4. Because I want to get a all by itself, so anything on the same side as my a needs to be brought over to the other side of my equal sign. So I have a squared is equal to 36 subtract 4, which is 32. And this is where I use my calculator. To go from a squared to a, I need to take the square root of 32. This isn't going to be a nice whole number, so I'm going to round my answer to 1 decimal place. So the square root of 32 works out to be about 5.7 when I round that up to 1 decimal place. And my unit is meters. So now that I've calculated my the height of my parallelogram, I can calculate the area of my parallelogram as well. So the area of a parallelogram is base times height. So the base of my parallelogram is 10. And the height of my parallelogram, which was a, which I found out from using Pythagorean theorem, is 5.7. And when I multiply 10 by 5.7, I get 57. My units are meters squared. So we're using what we learned from Pythagorean theorem in our last unit to help us out with area in this unit. Everything about math is connected, so it's really important that you have a good foundation of each unit before we move forward to the next one. The next example takes a look at this compound shape, or this composite shape. So we have a rectangle and a triangle. So I'm going to show this division of this shape by showing this dotted line there, so I can clearly see I have a rectangle and I can clearly see that I have a height, okay, or a triangle. This forms a right angle triangle. Right there, so that I can label my sides. Across from my right angle is my C, my 5 is my base, and I'm going to eventually calculate this little dimension right there, because in order to find the perimeter of this shape, I need to know what this length is here on this right hand side, and I'm not quite sure what that is because I don't know how high this part up here where A is, so I'm going to need to calculate that first. So down here I know this is 3 meters because this is the same as the top of my shape, but I'm going to use Pythagorean theorem to solve for my A. So I'm going to do that first. So a squared plus b squared is equal to c squared. Remember, I don't know what my a is yet, but I'm going to calculate that. My b is 5, so 5 squared, and my c is 7, so 7 squared. Solving my exponents first, 5 times 5 is 25. 7 times 7 is 49. Remember, these are 7 times 7s, or the number times itself, not 7 times 2. So now I have a squared is equal to 49. Bringing in this 25 to the other side gives us negative 25. And I can use my calculator to solve that. So 49 take away 25 gives us 24. So a squared is equal to 24. But I want a, not a squared, so I have to take the square root of 24, which gives us an answer. Again, it doesn't round up, it's not a whole number, so I'm going to round this up to 1 decimal place. So a is going to be approximately 4.9, and my unit is meters. So now that I know the dimension of the height of my triangle, I can now figure out what this missing piece is right here. So in order to do that, I need to take a look at the entire height of this shape, which is 8 meters. And I want to subtract just this little part right here, which I just calculated was 4.9. And that gives me a value of 3.1. So now that I have this dimension right here, and you can see that my diagram is not to scale, so don't let those dimensions fool you, then I can figure out what my perimeter is. And perimeter, I just add up all sides of the outside of my shape, so I'm not going to add in this a value right there at all. So for part A of this question, the perimeter is equal to, I'm going to start down here at the bottom and go in a clockwise manner. So 3 plus 8 plus 3 plus 7 plus 5 plus 3.1. You can do this all in one step in a calculator if you want to, or you can add this up in your head, practice those mental math skills. 3 plus 8 gives us 11. 11 plus 3 gives us 14. 14 plus 7 is 21. 21 plus 5 is 26. And 26 plus 3.1 is 29.1. And my unit is meters. Now to calculate the area of my composite shape, I need to look at the different parts of my diagram. So I'm going to label my triangle as 1 and my rectangle as 2. So the area of shape 1 is length times width. It doesn't matter which one you label as your length and your width, so I'm going to make 8 my length and 3 my width. If I switch those around, it's going to give us the same answer regardless. So 8 times 3, it gives us 24, and my units are meters squared. The next thing I want to do is calculate the area of shape 2, which is my triangle. So the area of a triangle is base times height divided by 2. This is where I needed to do my calculation for Pythagorean theorem as well, because I needed to calculate the height, or the A, of my triangle. So my base of my triangle is 5. The height of my triangle is 4.9. And I'm going to divide that by 2. You can do this in one step in your calculator if you'd like to. 5 times 4.9 gives us 24.5, and 24.5 divided by 2 gives us 12.25. I can round this to 12.3 to keep 1 decimal place like I've done for every other part of my question. So now I have and I put my units, so meters squared. I have the area of my shape 1, which is my rectangle. I have the area of shape 2 of my triangle, which is 12.3, and I need to find the total area. So the total area is the area of shape 1 being added to the area of shape 2. So I have 24 plus 12.3, which gives us 36.3, and my units are meters squared. And this is how we use Pythagorean theorem to help us solve for some area questions.